grade. Today we're going to work on some puzzle problems. We're going to work on age and numerator and denominator problems, word problems. So today we're going to work on age and fraction word problems. So if you could write that down in your binder, that would be great. Today is March 17th. What day is March 17th? What's the leprechauns? What is that? St. Patrick's Day. I should know that. That's why I have green on for you today. Anyway, if you have that down, I just want you guys to notice that we are at the end of chapter 9. So we're going to take 2 days to work on these types of problems. And then we've got the chapter review, the chapter test, and the cumulative review that we're going to work on. So the rest of this week, we are going to have a test, and the test is going to be turned in on Friday. So I'm going to need to see your work, you're going to have to turn it in, and you're going to have to use some moral fortitude not to cheat. So I need you to make sure that that's an important thing that you're thinking about. A lot of things that you're going to be having to do over these next couple weeks is to actually be true to yourself and make sure that you're doing your work and you're learning how to do things, figuring out how to do things, and you're actually getting your work done. Because this is not just time off. Unfortunately, this is time that we have to use and learn and continue our growth and development in math and as people. And so I need you to make sure that you are doing your work and you are not cheating. Because remember, in the end, you're only cheating yourself. It doesn't hurt me when you do that. All right, I'll get off my soapbox. So let's get to this. If I asked you, how old are you right now? A lot of you would say 14. If I said, well, how old were you last year? Hopefully everyone says 14 minus 1, 13. If I asked you how old you're going to be in 5 years, you would say 14 plus 5, 19. So when we do these puzzle problems that deal with age, we have to understand that the variables for how old you are now can be like X. That's how old you are now. Obviously, you know you're 14, but a variable, Ruby remembers this. But a variable is representing any number or anybody's problem, not just you guys. So if that's my age now, then my age in 5 years is going to be, my age 2 years ago is going to be, so this would be now, this would be in 5 years, and this would be 2 years ago. So in these problems, you have to make sure that you're aware of which situation you're dealing with. Let's look at an example. I'm on page 445, example 2. Mimi is 4 years older than Ronald. Mimi is 4 years older than Ronald. Okay? So we're going to give Mimi M. That's her age now. And Ron, his age now, is an R. An equation that I can write from this is Mimi, who is M, is, put your equal sign, 4 years older than Ron. Then the end rule says Ron goes first, Ron plus 4. That's your first equation from those words. The second part says, 5 years ago, very important here, we can't use M and R for 5 years ago. M and R are her age, their ages now. So 5 years ago, that's going to be M minus 5 and R minus 5. Everybody comfortable with that? 5 years ago. So these are the variable the variable expressions that I'm going to use when I'm dealing with this next sentence, which is 5 years ago. It says 5 years ago, she was twice as old as him. So remember, we're going to be using a system of equations to solve these word problems. So here's our first equation. It has two variables, so I'm gonna need another equation that has two variables so that I can use substitution, elimination, or if you're in the mood, graphing, to solve and find my answer to what they're asking for. So 5 years ago, she was twice as old as Ronald. So she, which would be Mimi, 5 years ago, and minus 5 was, put your equal sign, twice Ron, twice R minus 5. So now we have our two equations, this one and this one. And they want us to find their ages now. So I'm looking for M and R because that's their ages now. But I had to use these variable expressions in order to write my second equation so that now I have a system. So step 1, step 2 would be writing these two equations, and 3 is going to be determining what method you'd like to use to solve this. Because it's kind of already in the substitution way, I'm just going to substitute this in for M. R plus 4 minus 5 equals 2R minus 10. I distributed the 2 to both. I'm going to solve for R. Let me clean this up a little bit. I'm going to move my R over here. I'm going to move my 10 over here. So I'm going to add 10 to both sides. Subtract R on both sides. Sorry, our Purell is in the way. So that leaves, this gives me 9 equals R. So that means his age right now is 9. Did I get it right? I did, yeah. I need to find out how old she is now. So I'm going to take this value and plug it into here. 9 plus 4, which is 13. So step 4 is to check, and 5 is to state the answer. Mimi is 13, Ron is 9. Let's do another one of those. Let me erase. 9 years ago, Frank was half as old as Marilyn. Now, his age is 2/3 her age. Find their ages now. Okay, let's write this down. 9 years ago, Frank was half as old as Marilyn. Now his age is 2/3 her age. Find the ages now. So step 1 is to set up the variables. How old are they now? Now they are, Frank will give F, and Marilyn will give M. If I write an equation using this, which sentence am I going to use for the now? This one. Now his age is 2/3 hers. Frank is 2/3 Marilyn. 9 years ago, F minus 9, M minus 9. This is 9 years ago. These variable expressions must be used to write the second equation. Frank was half Marilyn. Not F again. We're talking about 9 years ago. So it has to be F minus 9 is half Marilyn. Really need the parentheses here, folks, because her age 9 years ago was M minus 9. It's not just M. So be careful on that. If you forget the parentheses, you'll forget to distribute, then it'll be wrong. Step 1 was setting up your variables. Here's 2. Yes, there's some fractions in here, but we know how to get rid of fractions to make our stuff look easier. What should I do? How do I get rid of the fraction here? Multiply both sides by, hoping you're saying 3. That would give me 3f equals 2m, right? What am I going to do here to get rid of this fraction 1/2? Hopefully you're saying multiply by 2. 2f minus 18 equals, remember over here, the 2 times the 1/2 is gone. Don't distribute it to this and to this. Remember, these are factors, not terms. So I'm multiplying this 2 times this 1/2, it's gone. And I'm left with, over there, m minus 9. So here are my 2 equations. I want you to stop the video, and I want you to finish this problem and do work on step 3, which would be to try to solve using whichever method you like. Stop the video and turn it back on to see the fantastic ages of Marilyn and Frank. Okay, step 3, I'm going to take 3f equals 2m and 2f minus 18 equals m minus 9. I'm going to clean this up. It's kind of funky. So if I do 2f, if I add 18 to both sides, equals m plus 9. A little bit better. Here's my m that I could use the substitution method for. So subtract 9 on both sides. M equals 2f minus 9. Take this, substitute it in right there. 3f equals 2 times 2f minus 9. 3f equals 4f minus 18. I'm going to move him over here. I get negative f equals negative 18. Multiply both sides by negative 1. I get f is 18. So Frank right now is 18. And Marilyn is 2 times 18 minus 9. 2 times 18? 36 minus 9. Oh, 36 minus 9. 6 is 30. 27. Marilyn is 27. So that's what we have. We have Frank is 18, so step 4 is to check. Step 5 is to state the answer. Marilyn is 27 and Frank is 18. Very important that we understand when we talk about 9 years ago, we use these variable expressions in our second equation. Not difficult, and it reinforces how to solve the system of equations for us. Not difficult. Okay, let's talk about the fraction problems.
Hey, I'm gonna stop it here.
Okay.
And then make this part 1.